Name of the chapter is capacitor. Number one topic is capacitance of a conductor. So in this case, in the diagram we have drawn a conductor and plus Q be the charge which is given to the conductor, and due to this charge we can assume that potential difference across this conductor will be V. And what should be the definition of capacitance of a conductor? So electrical capacitance of this conductor is a measure of ability, to store electric charge. So here in this diagram, so if plus Q, if the charge Q, if the charge Q is given to this conductor, so this is the conductor, to a conductor, so that its potential increases by an amount V be the increase in potential or change in potential. In that case, what we can say, the amount of charge will be directly proportional to potential difference or increase in potential difference. Therefore, Q is equal to a constant CV, the constant of proportionality, into potential difference. So therefore, C is equal to Q divided by V, charge divided by potential difference. This will be the potential capacitance or electrical capacitance of the conductor, charge by potential difference. Electrical capacitance or capacitance to store charge in it, capacitance of the conductor, So Q is the charge and V is the potential difference. Here, therefore, we can say what will be the definition of a capacitance of the capacitance of a conductor. Capacitance, the capacitance of a conductor. Capacitance of a conductor is defined as the ratio of the electric charge here Q is the electric charge on it to its electric potential, means V, electric potential due to that charge. So this is the definition of capacitance. Capacitance of a conductor is the ratio of electric charge and electric potential due to supplying that charge to the conductor. Here, hence we can say that capacitance is equal to charge by potential. Then what should be the unit of capacitance? That is, we have to mention. Here we can write the unit of capacitance. unit of capacitance is number 1 farad, that is the SI unit. Farad, which is SI unit. Another unit is coulomb per volt. Coulomb per volt. Coulomb volt inverse. Coulomb per volt under bracket, that is C V inverse. Number 2 is stat farad, which is CGS unit. Stat farad, which is CGS unit. And in this case, we know that capacitance of a conductor is the ratio of charge divided by potential difference. Therefore, you can say that 1 farad is equal to 1 coulomb divided by 1 volt. Hence, we can say that 1 farad is equal to 1 coulomb per volt. 1 coulomb per volt. Relation between farad and coulomb per volt. And we have other units of capacitance, that is other small units of capacitance, that is if we write 1 microfarad, that should be 10 to the power minus 6 farad. And if we write 1 picofarad, PF, that is 10 to the power minus 12 farad. This is actually picofarad. And also we can relate between stat farad and farad. Stat farad is the CGS unit of capacitance of a conductor. So stat farad is how much farad, that is we have to know, and that is also important. We can write 1.1126 into 10 to the power minus 12 farad. 1.1126 into 10 to the power minus 12 farad. That means obviously farad is much greater than stat farad. And in addition to this, what we can write, 1 stat coulomb. Coulomb is the unit of charge. 1 stat coulomb is how much coulomb, that can be memorized. It will have same type of relation, 3.33 into 10 to the power minus 10 coulomb. Coulomb is the SI unit of charge and stat coulomb is the CGS unit of charge. And if we write down the relation between stat volt, which is CGS unit of potential or voltage, and volt, and that has different relation. In this case, volt will be less than the stat volt. Here, volt is the SI unit. Though it is SI unit, it is less than stat volt, because 1 stat volt is equal to 300 volt, and which is also important. That is 1 stat volt is equal to 300 volt. Now, additional information, that is what are the factors on which capacitance of a conductor depends. Capacitance of a conductor depends upon its shape and size. Size of the conductor, shape and size of the conductor, shape and size of the conductor. And also it depends upon the nature of the medium in which it is placed. Nature of the medium. Nature of the medium in which the conductor is placed. Nature of the medium in which it is placed. In which it is placed, but it does not depend upon the nature of the material of the conductor. The nature of the material of the conductor. The capacitance of a conductor depends upon the shape and size of the conductor, and also it depends upon the nature of the surrounding medium in which it is placed, but it does not depend upon the nature of the material of the conductor. This is all about the capacitance of a conductor.